just start with a few announcements about this week, and then I'm going to talk about Mass Spectrometry 2 worksheet. So this is Monday. Today's assignment is to work on the Mass Spectrometry and the Mass Spectrometry 2 worksheets. Tomorrow and Wednesday are work days, so you'll have a work day at home and a work day at school. And then Thursday is multiple choice at home for you guys, and Friday is free response in class for you. Everything is due Friday at 3:15. You'll have 2 work days. You'll have the rest of today to work. If you have questions, let me know, but everything's due Friday at 3:15. That's when Unit 1 will be over. Okay, so Mass Spectrometry 2 is a slight variation of the mass spectrometry that we've already talked about. So the mass spectrometry we talked about earlier in this unit was just looking at a single type of element and its isotopes. So we would have carbon, and it would have 3 lines for carbon 12, carbon 13, and carbon 14. But a mass spectrometer can look at a compound, and it can give you an idea of what the compound is and its purity. So the most common use of mass spectrometry is in organic chemistry. And in organic chemistry, there have been mass spec graphs like this one made for all kinds of organic compounds. And then organic chemists can take their substance that they want to be pure, that they're trying to check its purity, and put it in the mass spec, make the graph, and then compare that with the pure graph, the pure sample, and see if theirs is pure or not. Because in organic chemistry, we're trying to make pure samples that don't have any other things in them, because often we're talking about things that are edible, or we're talking about medicines. That's what organic chemistry is. And if you are working at a pharmaceutical lab, you want to make sure that your drug is pure. When I say drug, I mean prescription drug. So this is a mass spectrum for this compound. This is methanol. It's 1 carbon attached to an OH with 3 H's attached to the C. It's CH3OH is what it is. And the way that the mass spectrum works for compounds is it just graphs the pieces. So here we have the whole compound attached to each other, which is 12 plus 16, 28, plus 4 is 32. So we see a line at 32. That's the whole compound with nothing broken off. Then we have one that's 1 less. That's one of the H's has broken off. Then we have one that's 2 less. That's 2 H's have broken off. We have one that's 3 less. 3 H's have broken off. And then down here, we have this one. This is 15. This is where OH has broken off, and we just have CH3 left behind. But what would happen is you would have this. This is like the accepted graph. You would put your sample in. You'd compare your sample's graph to this graph and see if you have any impurities. And it never failed in organic chemistry class. I always had a giant line at 18 in every single one of my samples. I had a huge line at 18. Any ideas what 18 is? Where it was coming from?
H2O.
Water. Often in organic chemistry, you've made something and you're supposed to dry it. You're supposed to spend some time in an evaporator drying your compound. And I was impatient. I always wanted to go home. Organic chemistry labs are 3 or 4 hours long. I was ready to be done. So I would hurry up and I'd put it in the mass spec, and it would come out with this giant line at 18. My professor would be like, "You didn't dry it." And I'd be like, "Yeah, I know." And then I'd get a C and I'd go home. But that's just how it goes. I'm not a lab chemist. I'm a theoretical chemist. I don't like labs that much, but there it is. Questions? All right.
Wait, so you